Yeah, tell me.
Yeah, hello Sunanda. Hello
Yeah.
everyone. Good morning and good evening. I'm Iqbal. I have one basic question. I know most of the answer would be yes, but
Mm-hmm.
still I'm asking. So there are big product-based companies, right? Like IBM, Google, Facebook.
Mm-hmm.
So everyone is building their end-to-end LLM model, right? They are building their own APIs and they are putting into the all the GPU server, right?
Mm-hmm. Yeah.
Okay. And what about the other companies like those who are customers like Bank of America or all these? I-
Mm-hmm.
I'm not talking about the regular chatbot. I'm talking about when they say they are implementing AI. Does it mean that they're using some APIs from different companies or they are building their own set of LLM APIs?
Correct. Anyone would like to take this question from the audience? I mean, this is a discussion, right? Feel free
Yeah,
to
I
answer.
can
Yeah.
take. I
Yeah.
can take that. So this is for, my friend's company. They implemented one decision making algorithm. It's an insurance company. Okay.
Okay.
Mm-hmm.
So what they did is they did not. For your question, they are not developing like Bank of America or any of them. They are not developing any LLMs by themselves because LLM development is a huge project by itself. So what
Yes.
they are doing is based on this scenario they are identifying which LLM use for them. So they have tried, if I take the my friend's use case, they tried ChatGPT, they tried Cloudy, and they tried some other LLMs, and they shortlisted or they identified Cloudy is the best fit, maybe on the pricing and also the output they are getting. So they leveraged LLM, Cloudy LLM, and on top of that, they build their own REST APIs and data pipelines and other things and build the application. So for your answer, they are not, they will be using whatever is the market, they test it out and they work on the outputs and the pricing and other things, whichever they think is perfect for them, they go with that.
Okay. Thank you, Praveen.
Exactly. Exactly. See, building an LLM or training an LLM is not an easy task. It's a very tedious task, and you need a lot of expertise in that particular, domain, right?
Yes.
You should have right amount of data. That data should be cleaned, that should not be biased, and on top of it you should have that hardware on which you can basically train your
GPUs.
LLM, GPUs and
Yes.
everything, right? So
Yes.
these big companies like Google or OpenAI,
Perplexity. Yeah.
Amazon, so they are basically training their own LLMs, right? So they are also buying these nuclear power plants to power those kind of setups. They consume so much of electricity as well. So it's not an easy task, right? Even for the IT companies which are there in the India or worldwide, they are not also building, right? Only a few are, I think, doing these things. Otherwise, what they are doing is whenever the LLM is there, they can use it off the shelf or they may fine tune it based on their requirements, right? That's what they are doing. So that's not their job to, uh, train or build these LLMs. Okay.
Okay, I got the answer. Thank you.
Yeah. So they go for any cloud platform. That cloud platform basically give them the services that okay, we have total of 100 different LLMs, so they have liberty to use LLM of their choice based on their requirements, right? So that platform like Azure or Google platform or GCP, AWS, these platform basically provide that kind of security where they can use the any of these LLMs hosted on, I mean, on top of it. So they can consume their APIs, they can build agents and things like that. All right, so let's recap what we did in the last class, what basically agents mean for the continuity. So we talked about what is an agent. An agent is basically a system that possesses the capacity to make autonomous decisions, right? So you can, compare that, okay, in terms of an agentic application, your LLM is basically your mind, right? Your brain basically, which can decide which tool to call. If we have a sophisticated task, what LLM will do is it will break it down into small subtasks, and then it will use its own brain or capacity to decide which tool to call to accomplish the task. Okay, so what they do is they take their autonomous decisions and take actions to achieve specific goals with limited or no direct human intervention. And we talked about React pattern. What is the React pattern? It's basically the combination of reasoning and action. React stands for reasoning and action. Okay, so in React pattern, what we do is basically there is a loop, there is a thought process. Whenever we ask any question, there will be some thoughts done by our large language model. And since we associate couple of tools with it, it will basically decide based on our prompt which tool is the best use, which can be utilized to accomplish that task. And then that tool will be executed. And then there will be some output, which is called observation, that will be brought back to the LLM to again check whether they need to go over the loop again or the task is being done, right? So it will keep on, executing in the loop until your task is fully completed. Okay, so this is React pattern, reasoning, and basically acting. And we took one example also, right? I hope you remember we create a system prompt where we instruct our large language model to work in a cycle or in a loop of thought, action, and observation. Whatever tools we have, for example, search Wikipedia or calculation or weather API, we define those tools, and those tools should be defined very properly so that LLM can understand what those tools can do, right? Based on that description only, LLM will be able to decide whether that tool is of its use or not. So we craft the prompt in such a way that LLM knows the capability of each and every tool, and based on the user prompt, it will decide whether to call the tool or not until the task is finished. Okay, so that was on the last lecture we have done. Now we are going towards building those agents with the help of a framework called LangGraph. Also, in the last class, we created one agent, right? If you remember, we created one Python agent without using any framework. So what we did was we wrote some Python classes, and we said, and our LLM was giving some output, and what we were doing were we were parsing that particular output to find out whether to call a tool or not. Okay, and if it has to call the tool, we were parsing which tool should be called and with what parameters. So now you can basically understand that method of creating that Python agent, which we did in the last class, is not very stable. It's not reliable, basically, isn't it? Because we are basically writing a prompt and we are associating the tools. We are not sure whether the LLM is going to pick the right kind of tool or not. Secondly, based on the output of the LLM, we were basically parsing using the what we were doing. We were using that what you call we were parsing those strings, and we were finding out which tool we need to call. So that entire process is very error prone. Okay, so it was not controlled basically. So what we want is we want some framework which can automate this tool calling also. Whenever LLMs outputs that, okay, it has to call a tool, it will automatically call that particular function or tool, and whatever output is produced, it should bring bring it back to our large language model. So that kind of automation we are looking for, and we want our coding efforts should be reduced, and lot of things should be handled by that framework. So the answer to that is using a framework called LangGraph. Okay, LangGraph again comes from where? It comes from LangChain. We already have deep dived on different concepts of the LangChain, what is runnable interface, right? We can use those runnable protocols to invoke. There are some set of methods which are available for all those objects, right? Any object, like for example, we have a chain. We have output parser. We can use those same set of methods like dot invoke or dot stream and things like that. On the similar lines, they have also developed a framework which is used to create the agents, and it's called LangGraph. And LangGraph also implements similar concepts. So now once we develop any graph using LangGraph, we can again do graph dot invoke, right? Also, it's not like that if you are using the whenever you are using the LangGraph, you have to use the LangChain, but it's very much compatible. It's good to use LangChain with the LangGraph, but it's not mandatory. Is it clear, guys? If you can see my browser, let me go to the website.
Are you sharing your screen? Because
You are
I'm
not
not
able
able
to
to
see?
see. No, sir.
Okay,
No.
just a second. Can you see it now?
Yeah, now it seems coming. Yes, now, yes. Thank you.
This also you can see, right? What is my browser?
Yes.
All right,
Yes.
so this is basically LangGraph. So this is again coming from LangChain. Okay, and you can see there are a lot of companies who have been using this particular framework for building agents. Okay, so what we have is, if I go back to my PPT, this we have done. All right, so what I was saying is, again there are basically a lot of frameworks. If I talk about, let me insert a slide. We have something called LangGraph, which we can use for building agents. We can also use, there is something called Crew AI. That is also another framework. We can use AutoGen. Okay, this is from Microsoft. We can use Microsoft Copilot, Copilot Studio also. This Microsoft itself comes with around 5 or 6 different interfaces for building these agents, right? But these two are basically the framework which are very famous, and we will be concentrating more on the LangGraph. Why? Because first of all, this is very much compatible with your LangChain, and also whatever graph which we create with the help of LangGraph, they are very controlled, right? So whatever nodes we build, whatever edges we build, that entire workflow is very controlled, and that can easily be deployed in the production as well. Whereas in case of Creo AI, we leave lot of things on the framework itself to decide which tool to call, how to execute, how to orchestrate. So that flexibility is more in the Creo AI. Since the flexibility is more in the Creo AI, the certainty is less, right? But in case of LangGraph, the graph or the workflow which we create is very much controlled, and it can be brought to the production as well. Okay, so this is what being said in the industry. Okay, so we'll deep dive into LangGraph now. In the LangGraph, what happens is we basically create such kind of graphs. Okay, so we have something called as the start node, and we have something called as the end node. So these are basically nodes. Start is a node, assistant is a node, assistant tool is a node. All these rectangles are basically nodes. And these arrows are basically called as edges. They can be conditional edges or they can be normal edges. Okay, so they define the flow of the information. From start, it will go to assistant. From assistant, it may go to assistant tools, or it may directly end, right? So there are two routes from this particular node. In fact, three, or it may go to the this node. right? So by using these nodes and edges, we basically decide the flow of the our graph. And what basically flows inside this is known as the state. Okay, so a state is basically an object which will enter into this particular graph, and its state will keep on changing from one node to other node. Okay, for example, I have defined one message state. Okay, so once that message states, when the user asks any question, one message will be appended to that particular object. And when that control moves to the first node, there will be some operation being done by node. Nodes are nothing but some operation. That operation can be done by LLM. That operation can be done by any function, Python function, right? So whatever operation is being done, the output of that will be again set into my state. So my state will change here. If my control goes to the assistant tools, again, my state will keep on changing. So throughout my journey from start to end in my graph, the state of my agent will keep on changing, right? So this we will see how we create these such type of graphs, how does we define the state and how it keep on changing throughout its journey in the agent. Okay. So we can, create such graphs where example, we have a start node. From a start node, we will go to the node one, from node one to the node two, and then we go to the end. So let's start building to make more sense. And let me open my VS Code. Again, I think you won't be able to see the VS Code. Just give me a second. Is my studio visible, guys? VS Code?
Yes.
Yeah.
Yeah.
So what I will do is we will first of all, let's go to Grok. We will use the Grok models. So let me choose the Llama model. We can use Llama 3.3 30B versatile. Okay. So let me choose that. Uh, Let me create environment file as well. .env. This is my app dot. This is my .env file. This is, let me create my virtual environment. I will go to terminal and Python -m venv agent is name of my virtual environment. Okay, my virtual environment has got created. Let me activate venv agent scripts. Activate. It has got activated now. Let's install pip install LangGraph library. And what else we need? We need LangChain, LangChain itself, and LangChain Grok as well. So let's install these. Meanwhile, in the
So when you do this installation, it's kind of like you're installing libraries, right, to your local system, which basically when you will run, it will interact with those their server.
correct. So these are the libraries. When I will write my code, those libraries will be used to interact with the,
Interpret.
yeah, correct. To connect with the
Okay.
Grok models or to use the different methods written by LangChain and all those stuff. Okay. So I think I created a folder here, right? Let's delete. It should be a file, not inside this one. Okay. So what I would like to do is import OS, and then I also need to install .env to load my environment file. Okay, so I also need to install pip install python.env. Here I can write from Python. It's not suggesting me today.
Maybe we have to call something in the workspace or install.
Mm, okay, I think this is not active. Let me that. Okay. So if you start using these coding assistants, you become so dependable that if it does not work, you are not able to code. Have you guys been using anything like Replit AI for building applications in your projects? Replit or Cursor? No one? You should explore all these things. One is Copilot, GitHub, GitHub Copilot. Another is a Cursor, okay, Cursor AI. And you can also try using Replit. This is very much famous these days. Another is Lovable, and there is something called as the Bolt, right? So you can Google all these things. What they will do is, if you are using Cursor, basically, you can build your entire user interface, right? You can write in your plain English what you want to build, and step by step it will generate those files and everything, packages, files, everything it will create, and within a single day, and if you are an expert, maybe in few hours, you can develop one full-fledged application. So these are so strong these days and very much being used in the industry. All right, so I think this should have been done. Now, what I need to do is import my .env using Python. Now it's suggesting me. Okay, so I have loaded my .env, but let me check. So, okay, so when you are choosing your large language model for building your agents, one thing is very important, which is your agent should be able to support the tool call that you need to check. Okay, for example, right now I am using this Llama 3.3 70 billion, and I should go to the model card and I should check whether it's supposed support tool call or not. Okay, tool use, it does support instruction tuned model. Tool use, okay, tool just like in the standard software development, I'm responsible for integration with the tool use and services, external tools. So this does support. It's not properly mentioned. Okay, capabilities. If you see this particular Llama 3.3, its capabilities include tool uses also. Okay, that means it supports tool calling. Okay, so you have to check. You should not be using any LLM which does not support tool call. What is the tool call that we will see again next in our class? So what about my keys? We'll copy my key, put it in my Grok API key, update it. So this is updated, and this is LangChain API key, and this is LangChain tracing. This is required for your for monitoring your application, right? We can say agents underscore session. Okay, so this will be our application will be basically monitored by LangSmith. LangSmith is again one product from LangChain which help us to debug our application. This we have covered, right, already. So these keys are required to log our uh, logs in LangSmith. Okay, I hope everyone is clear. So now we have loaded our .env file. What next we need to do is we need to start building agent using LangGraph. Our libraries are also installed. So let me take some code. So our first step is to define, there is something called state. We talked about state, right? So whenever we are building our LangGraph, there will be one state object which will travel across from start to the end. Okay, and its state will be keep on changing from one node to other. So we are defining that particular object, and that object is called as a state. You can name it anything, but I am naming it as a state. And what is its type? It's a typed dictionary. Typed dict means it's a typed dictionary. Dictionary you already know, but in this case of typed dictionary, what we are saying is whatever this dictionary will have, it will have one key called my underscore state, and the type of this key is string basically. So it can store only string objects. Okay. So if you're confused, maybe you can go to your chat GPT and just ask what is difference between Python dictionary and typed dict. Okay. So your Python dictionary can have your, any kind of data. But when you say typed dict, that means it will be of, for example, name is Alice, age is 30, and he is employee. So this person is a dictionary. In case of type dict, basically you tell what is the type. Your name will be of the string type. Your age will be of integer, and your is employee is will be of your boolean. So you are basically defining the type of the data which your dictionary will be storing. That's it. Okay. So we have defined that my state, this state dictionary will have a key called my underscore state, and it is of string type. Okay. So we are done. Now what next is, let's start defining our nodes. And as you know, what are nodes? Nodes are nothing but they are Python functions. They are what? They are Python functions. Okay. So my node one is like, it will take state as an input. So we said our this graph will be having one state object which we have already defined, and the key is my underscore state. That state will keep on changing throughout the journey. And now what we have defined is we are going to define these nodes. Okay. And these nodes, as I said, they are nothing but they are Python functions, or they can be LLM calls, they can be anything which will manipulate the state. So I am defining this node one. It will take state as an input for sure because it is going to change the state. So it will take state, my this object as an input. And what I am doing is I am simply making a print statement that what is my current state, what is value of this particular key as of now when this node is being invoked. Okay. And then I'm again defining a new state, and what this variable will do, it will take the existing state. Okay. This is again dictionary. In the curly bracket, we have the dictionary, and this is the same key which we have defined. But what we are doing is we are taking its existing value state with the my state will give the value of my state key, and it will append this particular string. I want to travel. Okay. Is it clear? I mean, it's a bit technical and it's needs some Python knowledge, but I hope this is clear now. Anyone who has doubts? Okay. So what we are doing is basically
Yes, can you explain it one more time?
one more
Can you
time.
please
All
explain
right.
it one
Yeah.
more time? Starting from the type.
So what? Yeah. So what I'm saying is whenever this node one will be invoked, it will be invoked with some state object. As I said, every node, once our workflow will get executed, every node will receive the state and it will change its state basically. Okay. So when this node one will be invoked, it will receive some state. Receive some state means it will receive some value of this particular key. For example, let's say I initialize this state with the statement, my name is Surendra. Okay. So my state key will be having value, my name is. So once that my name is will enter, okay, what I'm doing is I'm fetching my current value and I'm appending this particular string. So the new state will become my name is plus I want to travel to. Okay, and that value is again getting saved in my new state, which I'm returning basically. Okay, so maybe I will execute, then it will make more sense. In this node 2, what I'm doing, again, I'm accessing my current value from the state object, my state key, and I'm adding it to Germany. And in the third node, I'm doing the same thing, but adding Italy. Okay, so let me execute this. Okay, so this is about defining our nodes basically. Okay, please mute yourself, everyone. So this is about, can you mute yourself? Okay, so now my next task is to define what? To define the edges. Okay. I have to connect these nodes, right? Let me complete the code first and then show you. So after defining my nodes, I need to join them, right? So what I am doing is, first of all, I am, or instead of this one, let me simply make it a bit simple, or let it be. Okay. Then I'm importing IPython. This is basically used to display my graph, whatever I'm developing. And from LangGraph, I need to import this state graph and the start and the end node. Okay. Then I initialize my state graph saying builder is equal to state graph, again with the state which we have defined. Okay. So this is very crucial. The state we have defined, with that state, I am initializing my state graph. And in the state graph, I'm adding my nodes, whatever functions we have written here, right? So these are just functions. Now we are adding those functions as a node in my builder. So I say add node and I give it a name called node 1, node 1, node 2, node 2, and the node 3. So these are the names and these are name of those functions. Node 1 is what? Node 1 is my Python function. Node 2, similarly, node underscore 2 and node underscore 3. Okay, so I have added my different nodes into my builder. Now I need to connect these nodes. So what I'm saying is I need to add the edges. Builder dot add edge from the start. What I want to do from the start, I want to connect to the node 1, just like this one. Okay, so this is like connecting from start to my assistant node, right? But in our case, where we want to join start to our node 1. So I have written node underscore 1. So be careful. You should not be writing just node underscore 1, the actual name of the function, rather the name which you have provided here, node underscore 1. Okay, so they can be different also. Okay, so in the double quotes, you have to give node underscore 1. From node 1, what we are saying is we will basically decide whether it should go to node 2 or node 3. So we are saying builder dot add conditional edge. Okay, so this conditional edge will decide whether whether the flow has to go to node 2 or node 3. Okay, so I'm saying conditional edge will basically connect node 1 with the decide destination. What is this? This is again a function which will say it will also take state as an input and its output are basically either node 2 or node 3. And right now it's basically doing a random choice between node 2 and node 3. In practical cases, there can be some logic, and then based on that logic, it will say whether it has to go to node 2 or node 3. For simplicity, it's randomly right now choosing between node 2 and node 3 as an output. Okay, so this is my decide destination node basically. So that I have connected with the node 1. From node 1, it is going to decide destination, and whatever destination it choose, it will be either node 2 or node 3. From there, I want to end my flow. Okay, and once I do graph builder dot compile, and then if I want to display that graph, I have to use this mermaid PNG function, and this is how my graph looks like. So let me reiterate. We will start our flow. Once we start the flow, it will go to the node 1, where I'm doing what? I'm just appending one statement. My node 1 function is doing what? It's just appending I want to travel to my input state. Okay, whatever input state I give, it will append this particular sentence. First, it will print the existing state and then it will append. Clear, guys? And then based on the decision node, right, it will decide whether it has to go to node 2 or to the node 3. If it goes to the node 2, it will again append one statement like either Germany, or if the node 3, it will go to Italy. Okay, so like that. So you can see wherever you have decision node, it will basically show it by the dotted lines. Okay. So this is basically a hello world for your agents, guys. Okay. So gradually we will replace these with the actual functions. For example, we can use our large language models. We will also club the tool calling functionality. But for the simplicity, in order to understand these nodes and edges, this is your hello world kind of agent. Anyone has any doubts on this particular
So,
graph? Yeah,
Surendra, basically nodes are some execution logic in a typical real world.
correct.
Like something
It
execute, and
can be
at the
like,
end it should pass a new state. That's mandatory.
yeah.
To
It will basically, from after execution of this one, the flow will go to next node based on some logic or some decisions. Okay, so either it will go to node 2 or node 3. From there, it can go back to node 1, or it can end, or
Mhm.
it may go to the node 2. So that entirely depend how we design our flow.
Okay.
Okay,
And how it looks like when we run the program.
yeah. So
I
that
mean,
we
I'm
will
not talking
see.
about the image part. Yeah.
Yeah, yeah. So I'm just explaining. So this is our graph is basically ready. We have instantiated the graph, we have added nodes, we have added edges, we have compiled, and we have also shown how it looks like in this diagram. Beautiful diagram. Okay. Now let's invoke this one. Okay. So invoke, as I said, graph is again what? Graph is also a, anyone? Graph is also a, since it is also coming from the LangChain, graph
It's
object,
runnable.
it's a runnable. So we can use the invoke. So it's as simple as that. Whatever graph we have done build.compile, whatever graph we have, we simply need to write graph.invoke, and then I need to pass my state. Okay. And in the state, I have one key, which is my underscore state, right? So I am defining its value, hello there. Okay. Hello there. My name is Surendra. That's it. With that state as an input, I'm invoking my graph. So you can see when it goes to the node 1, it says, hello there, my name is Surendra. This is my current state. And then, hello there, my name is Surendra. I want to travel to, and then my state, hello there, my name is, I want to travel to Germany. Okay, so it failed to lock to the Langsmith. You can ignore it. Okay. I think the API keys are not correct. These keys. Okay, so you can ignore that. But yes, we are able to execute our. So if I run it again, what will happen? Maybe next time it will go to node 3 and it will print Italy, right? Let's say Italy. I want to travel to Italy. Okay, Germany, Italy, Germany, Italy, Germany, Italy. Okay, so this is how I invoke my graph. I can write anything as an input. Okay. I'm from India. And if I execute now, it will say the output is hello there. My name is Surendra. I'm from India. I want to travel to Germany. Next time it may go to node 3 and the output will be Italy. Good
But
enough.
who decides which node it will go through.
Yeah, so this logic we have written, right? Decide destination. So it is using one Python function which is random. So randomly it is right now giving node 2 or node 3. Okay. In real world, we will put some logic. Okay.
Okay.
Or LLM may decide which tool it has to call. So it will give the tool as an output, tool 1 or tool 2. Right? If I say you have to use, you have these three tools, tool 1, tool 2, tool 3. First tool is doing some mathematics, some calculations. Second is basically using Wikipedia. Third is calling weather API. And if my question is what is temperature in Delhi, so it will use the third tool, right? To get the weather of the Delhi, isn't it? So my LLM will decide, okay, it has to go to node 3 or the tool 3. Clear, everyone? So that's what we want to build. Right now, we have hard coded this logic, but gradually we will replace it with LLM and let LLM decide where it has to go.
Can you please run once more, telling each line how the control passes through?
This from here or from the code?
No, the display, Germany and Italy.
This output?
Yes, yes.
Okay. So what I'm doing is this is my initial state. Okay. So when I'm invoking my graph, I am giving my state. Okay, my
So I
state is
can,
a
yeah.
dictionary. So this is a dictionary and the key is my underscore state. And the value I am giving initially is this one. This can be anything.
So if I understand this one, I can
Mhm.
consider like Java, and I can say like this is the main of the program.
Yeah, you can say. From
Okay.
graph.invoke, what will happen is this particular interface will be used by the user to ask any question. Okay, rest this agent will get executed. Getting? Whenever we have any chatbot application, whatever user is typing in the chat box, that is this piece basically. I can ask any question, right? So that question will be taken from that text box. It will be set to my state and my graph will be invoked. Okay.
Okay, so this will print the first line, then the cursor will move to the node 2.
Yeah. So if you are trying to visualize from the end user perspective, once the user asks this question, he will directly get the final answer, right? So this is for debugging purpose. We are just printing what is going in the node 1 and node 2. Okay. For example, my question can be what is temperature in Delhi? Okay, so that will be question. So the user will write the question what is temperature in Delhi, and as a final output based on its logic, the LLM may decide, okay, I have three different tools. My tool number 3 is the one which can tell me the weather in the Delhi. It will call that tool, it will give the output and it will end basically. Right, so finally I will get the temperature in the Delhi is 28 degrees Celsius. Okay, so this is for debugging purpose. I'm just printing all those things, right? If you go to my these now, I'm just printing these one.
Yeah, node 2, node 3.
Okay. In my node 1, I am printing my current state, not the updated state. Updated state of the node 1 is getting printed into node 2. Okay. Or if you want, I can also give a print statement here as well.
Okay.
Okay. Node 1, hello, my name is down to table 2. Got it?
Yeah, thank you.
This is right now same because in the node 2 also we are first printing the current state. Current state for the node 2 is the final state of the node 1, right? So you can just play around. Everyone is clear? किसी को कोई क्वेश्चन है तो पूछ लो. There is nothing. So this is your first hello world kind of agent. Now we will bring some
Sir,
complexity.
yeah, just
Yeah.
one question I have.
Mm-hmm.
Can you just tell me how we have ended actually these edges? I got to know that node 1 and node 2, you have created some edges. That
Mhm.
I just need to know end part and how we just added it to the end
Yeah.
in terms of.
So what I'm doing is once from the node one, I am using the deciding node to decide whether to go to the node two or the node three. Correct?
Right,
And then
right.
so what I'm doing is I'm joining conditional node one to this decide node, and decide node will decide node two or node three. Right? From the node two and node three, I'm saying certainly it has to end basically. So they are ending it.
And okay, and is a variable we have imported from the module.
Yes, yes. So this is
And
and start and end
yes,
is coming from the library. LangGraph,
from library, yes,
state graph, start and
yes.
end. Okay. So they are already
Okay, got
defined
it.
things.
Yeah. You scroll so fast now, so I just missed this
Oh,
particular line actually. Yeah, thank
yeah,
you.
yeah. Feel free to stop, guys. है ना? कुछ नहीं समझ में आता तो feel free. All right.
Yes, yes.
So what we can do is we
No.
can also, I mean, the conditional edge we can decide in a way that it can go back to the node one, and then again there can be some logic, and then it will decide again whether to go to node two again or node three. So that all depends on how we build our graph. Okay, so let's now move to one important concept in agent part, which is called tool calling. Okay, so let me, for that, let me use OpenAI. So if you are using this Grok, I mean, for small projects, it's fine, but sometimes it does not work well. So OpenAI models are the best ones, which works well with these agentic applications. So I am just installing. I'm just installing OpenAI as well. Okay. So meantime, let me check my OpenAI keys. So I'm just creating new key for my OpenAI, and I have copied my key. Let me put it OpenAI. All right. What next? So this has got installed. Okay. So you have not seen any log because I used this -u and q. Q is basically for quiet installation or silent installation. Okay, so it has installed OpenAI. Now I can use my OpenAI LLM. So this I think I don't require. I must have got OpenAI key. So what I'm doing is from LangChain underscore OpenAI, I am importing chat OpenAI, and I have defined one method called multiply. A, it's taking two arguments, A and B, both are integer, and its output is also of integer type. Okay. And I have defined clearly. So this is called doc string. In the doc string, I have defined multiply two numbers, and the A is the first number, B is my second number. So this is how you need to define your tools. Whenever you are writing tools for your agents, you have to define those tools very, very carefully. You have to write this doc string in the triple quotes, means you have multi-line comment. Okay, in the triple quotes, you have to define what your function is going to do. For example, this multiply is basically multiplying these two numbers. What are your input variables, arguments A and B? You have to define them carefully, and it's returning A into B. And then I am using chat OpenAI. Model is GPT-4o mini, and this is called tools. This is my first tool or first Python method. So in the list, basically, I am assigning it as a list. Basically, I am adding it. If I have 2 or 3 tools, I will just put comma, 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 and add all my tools here. So this is the list of my tools. Okay, my methods or functions, whatever you call. And then what I need to do is whatever my LLM object is there, there is a method called bind tools. So I will bind my LLM with these tools. So that is very much equivalent to doing in the first lecture, right? We write a system prompt that you have access to these 3 different tools and blah, blah, blah. So now we have LangChain provides us a method called bind tools, with the help of which whatever associated tools are there, we will associate those tools with my LLM. Okay. So let me run this. It worked. And now if I see what is there in my this particular LLM with tools object, I can see. So what I'm doing is pretty print. There is something called pprint. From pprint, import pprint, and pprint LLM, this new object, after binding my tools, and I am converting it into dictionary basically, so that I can see all the objects, all the keys basically. So my first is bound, that's fine. Config, input. Now you can see there is one node called as tools. Okay, within that tools, there is a description that, okay, so there is a tool called multiply 2 numbers. The name is multiply. What it is doing is it is multiplying 2 numbers. Its parameters are like A and B, the first number, the second number, required A and B, so on and so forth. Okay, so this tools property is get populated. Okay, so let's say if I do something like, if I, instead of doing this, I simply use the object which is without these tools. If you see this under the microscope, you will see the tools part is empty basically. It's in fact not there. Async, cache, client. So there is no tool basically. RST. It has not even populated the name. Okay. So there is no tool. If you talk about only LLM object, the OpenAI large language model object, there is no tool associated. And once you associate your tool, you bind these tools which you have created. What it will show in the properties, if you go, it will show you it's going inside the KW arguments basically. It's not showing that. Okay, so there is no tool in this particular object, but if we bind it, it will have this description inside it. Okay, I am explaining you this because once we call this or use this LLM with tools object, okay, once we invoke this particular thing with our questions, now the LLM knows that it has couple of tools associated with it. So it can use these tools based on the description of what we have provided in the tools. Is it clear, everyone? समझ में आया मैं क्या करना चाह रहा हूँ? Yes, no?
थोड़ा थोड़ा
हाँ, what we have done is we have created one tool. ठीक है, tool is nothing but it's a Python function. Okay. Acha, let me tell you one more thing. Let's say if I want to do something like uh, LLM dot invoke. Okay. And if I want to multiply, let's say multiplied by, do you think it can give me the right answer?
No, don't have the model.
Outside of boundary, as I said, a
Outside
value.
boundary. क्या हो गया इसको? Incorrect API key. Why my key is not working? Just a second.
I think you are not run the .env. .env.
Oh, okay. I need to reload the .env. Okay, that
Yes.
could be the reason. Super. Yes, that should be. That can be the reason. Let me. ZR. It's different, isn't it? JHR, and this is ZR. It's not loading. Let me. Okay, so what it has given is this answer. So let's check if it's correct or not. So this is 26, so you can see 2633 and LLM is giving 2628. Okay, so why LLM is not able to multiply? Anyone? Because LLM is not trained that way, right? So LLM is doing what? LLM is trained to predict the next token. It is not efficient or not capable of multiplying or doing mathematics. Okay, so that's why we use tools. That's why when we create agents, we cannot rely on LLM's capability. Rather, we create those tools which can help LLM to do task for them. Okay, so this cannot even multiply these two numbers. So in order to multiply these numbers, what we can do is we can create some custom function. That's what we have done. We have created this custom multiply function. And what LLM will do is if LLM knows, okay, I have access to this tool, and if the user is saying, I want to multiply these two numbers, it will, instead of trying himself, it will use this tool, will call this tool to get the multiplication done. Now, I think you must have understood why we use tools and what is the rationale behind it. Clear, everyone? All we have done is we have created this multiply function and we have created a tools list. This can have multiple tools, and I'm telling my LLM with a function that you have access to these many tools. Now it's up to your judgment which tool you call basically. Hope this is clear now. So if I just see the LLM, I won't see any tool description. Once I bind it with the tools, I can see there is a tools option which has all the details of the function. Okay, सबको समझ में आ गया यहाँ तक? All good?
Yes.
So now let's say I invoke my LLM with the tools with the question, what is neural network? Okay, I will take the response and I will break it into dictionary. So what do you think? The tool will be called or not?
No, it should not be called, right?
Correct. So when I invoke this, so what it will say is the my reply is inside my content. Okay. So in the content, what it will say, a neural network is a computational model inspired by the way, blah, blah, blah. Okay. And there is no, the tools call is basically empty. Okay. Because now the LLM has decided it should not call the tool basically, which is associated with it. Rather, it's a simple question which it can answer. So it can invoke tool only and only when it's required basically. Is it clear? This is very important concept, guys. Okay, so right now the answer is coming inside my content key. Okay, my entire answer is coming in my content and my tools call option is blank. Now, if I ask him some question like the earlier question, which it was not able to do, I give same multiplication, let's say, multiply these two numbers. Let's see. So now you can see my content portion is blank. Okay. And it is in fact saying that I should use the tools call, and the name of the tool is the multiply, and the arguments are A and B. This is my first number, this is my second number. So it is populating those two arguments and it is giving me the multiply, the operation or the tool name basically. All in all, it's not basically calling himself that tool, rather it's just telling us that a tool should be called with these arguments. This is very, very important concept. You have to see 10 YouTube videos to understand this. Okay. It took me also to understand this concept. Aapka LLM is not LLM tool को call नहीं कर रहा है himself. It will not call this multiply and will execute the tool. It will just tell you that you should use the multiply tool with these arguments. And it's now up to us to execute this particular function. Is it clear, everyone? ऊपर से जा रहा है क्या? बता दो. Uh,
So is that refusal is none in the sense that is not calling that tool? Yeah.
no, refusal is something different, but the content is null basically. Earlier, I was getting my answer in the content, right? If LLM respond
Yes, yes.
anything, it always respond in the content. Right now, it's not responding anything. Rather than it's telling us that you should call this tool. This is the best thing to call. Instead, me answering the question, you have seen, right? If the
Yes.
LLM calls, it's not giving me the right answer. It's just hallucinating. Okay. So it will just give me the signature or the name of the tool and the arguments. Now it's up to me to execute this tool. Okay. This is doing only the judgment. We said, right? React reasoning. This is doing reasoning. It's telling me the tool name. That's it. And the arguments. Nothing else.
Yeah.
It
What I
himself,
should do? Yeah.
it cannot call that particular function or whether API. It can just tell me what signature I should use, basically. Okay, good enough. All right, so now next, we have seen this one. Let's build another agent. Okay, this is my next agent. This is my tool calling node. This is my initial state. This is my AI message, human message, and this is the message state. I think. So in order to build my next agent, what I need to do, again, I need to tell what is my state. Okay. In the last example, we had the name of my state as just state. And we had just one key, which was my underscore key. Okay. And I was appending some text. Now in this particular agent, I'm going one step further. We are moving more towards some practical use cases. So now I am deciding a message state as the class or the name of my state. And what it is having is it is having some messages, right? Because when we talk about large language model, what will happen? We will send one message and it will give me some output in the message, right? So now instead of having that my underscore state, I am defining messages as my key. And what is its type? Its type is base message. This is also type dict. And the type of messages which this messages key will carry is message base messages basically. Okay, all my AI message, my system message, and my user message, they all inherit this base message basically. They are coming from this base class only. Okay, so this is my base class. This is coming from directly from the LangChain APIs, and this basically has base message chunk. There are operations defined. Base abstract message class. So this is the base class basically. If I go to, let's say, if I go to AI message, there I can see. कहाँ गया गया नहीं. If you go to human message, this is basically coming from my base message. Okay, समझ गए ना? This human message, AI message are basically type of base messages in short. So what I'm doing is I am defining my state, and this time I'm saying that my state is like messages. The name of the key is messages, and what it will have lot of base messages kind of objects, list of that. Okay. And then once I define my state, again I'm doing the same thing. My initial state I am defining AI message content. Hello, I am Sherlock Holmes. This is human message. Hi, I am John Watson. How do you solve a mystery? Okay, I have defined the initial state by defining two different messages in a list. Okay, this is a list of messages. So this is also a base message, kind of base message, and this is also a base message. So my input is ready. Now I am defining tool calling node. Okay, and what it will take as an input? Message state, and this is printing. I'm just printing the existing messages in my state, just iterating through, and then this is the for loop. And in the response, I'm saying if I LLM with the tools, if I invoke my large language model with those messages, this is the response I will get. And again, I'm just printing some hashes and leaving the LLM node. I'm setting my response in my messages. Okay. And then this is my builder state graph. Again, it will take message state as an input. I'm adding my node, tool calling node. This is the name I have given. This is the name of the method I have written, tool calling node. From start, I'm basically going to my tool calling node, from tool calling node to end, which is very simple graph basically. And again, builder.compile. If I want to display, I can display my graph. This is very simple graph. From start, it will go to tool calling node. Okay, and from there, it will basically end. So all I'm doing is inside this particular, just one node is there. And this is basically a tool calling node. It will invoke my large language model. Okay. And whatever output will be there, it will append to my state, which is my messages. Okay. And one beautiful thing about this is that it will, if you return messages as the response, it will not replace the existing message. Rather, it will append that response to my existing messages. Okay, so this has been done in the LangGraph itself. That automation is there. So you need not to explicitly, earlier we were just appending those texts, right? So here we just need to return the response, but it will get appended automatically. Under the hood, they have written the code which can append the response into my stack of messages. आ रहा है समझ में कि सबको या फिर ऊपर से जा रहा है?
नहीं नहीं समझ में आ रहा है। यहाँ
आ
पे
रहा
हम
है?
लोग मतलब ये कर रहे हैं कि दो मैसेज, एक एआई और एक ह्यूमन वाला,
हाँ, ये मेरा
उसी को
इनपुट
हम
हो
लोग
गया
ट्रेन कर।
बेसिकली.
हाँ जी।
राइट. और फिर what we are doing is we are calling our LLM and then with those messages and we are getting the response. That response we are sending in the messages again. Okay, it will
But
get
why
up.
it will,
Hmm.
yeah, sorry, but why it will append? You said
It will
it
append
will.
because, right, because if I'm going from one node to other, I should have history of my
Oh,
conversation, right?
yes, 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 yes.
Correct. So that is very important. So that's why it will keep on appending the messages, because once, let's say I have built a graph where from here it will go to some other place. So it should have history, what it has done earlier, right? Whatever operations has been done, then only it will decide, okay, what is my next operation? If you recall the first lecture, we were adding our, we were finding the mass of all the planets and then we were adding. So if you are not appending the mass of different planets, how we can add them, right? So in the history or in the messages, I should have a history what I have already done so that I can decide my next course of action. Now, once I have the mass of planets, now I need to add them. So I will again propose a tool call with the arguments of all those masses, and I will say call the calculate tool with these arguments, right? So I have to maintain the history. चलो इसको कॉल करके देखते हैं. लेट्स इन्वोक दिस वन. Again, I will do same thing. Right now, my initial state is already ready, right? This is my initial state. So I will simply set my initial state and I will invoke my graph. So what it is telling is entering LLM node. So all these have basically put inside our node itself. Entering LLM node. This is my AI message. I am Sherlock Holmes. I am John Watson. How do you solve a mystery? And this is my AI message, AI response basically. Okay, it's clear. Simply what we have done is whatever we were calling earlier, just like those calculations or something, I have put that large language model operation inside my agent. Okay, and it has not invoked my tool because my question was like that only. Okay. Correct, guys? This LLM with tools was having tools also, this calculator tool, right? Multiply numbers, but it has not invoked it because there was no necessity. The question was not about
We did not
multiplying,
call it.
right?
Yeah. But how it was displaying that star with 80 things, like if you go a little up, human
Huh.
message, there is a
Mm-hmm.
equals to sign, right? E- Entering LLM model and input message. Can you please show like how it is printing? Entering
So,
LLM model node.
mm-hmm. So this is everything is here, right? So when we enter, so we are printing this hash 80 times. Okay, so that's
Yes.
why you are seeing this 1, 2, 3, these 80
Yeah.
hashes for the presentation purpose. And then entering LLM node and whatever initial, I had two messages, right? So it's first displaying those two messages. Entering LLM nodes, this is the AI message and this is my human message. Okay, so these two messages were already set right here. AI
But how it
message
is, yeah, but how it is deciding that equals to then in between AI message?
deciding.
Can you please
So,
go to the output?
see, this is my messages, right? Within that messages, I am setting all these things. Initial state is basically going into my messages key.
Yes.
Here it will go into the messages key, and then I'm iterating whatever messages I have. If I have 2 or maybe 10 or 50 messages, I'm just iterating those messages, and then I'm doing message dot, I mean pretty print.
Okay, pretty print. Okay.
Pretty print, yeah.
And
This
it will
pretty
decide the length, right? Accordingly. 80. By
uh
default, the length of the pretty print is
actu-
deciding accordingly as per the 80 we
yes,
set,
this one,
right?
this one.
Yeah.
No,
Yeah. Yeah.
I mean that 80 was to put these 80 hash marks basically. Okay, so this is done by pretty print by itself. So I mean the pretty print is a function which basically shows your output in a readable manner basically, right? So that these formulations or these fonts, all those things are there in the method itself. This is how
Okay.
it
Thank you.
shows the messages, you know. Okay, so that was simple enough. So we had the LLM, but with the tools, but it didn't use the tools because there was no necessity. Earlier we did outside the agent. Now we have put our node inside the agent. What's next? What we can do? If I ask some another question, if I ask my mass question now, what I can do is I can ask, just I can put one message, graph.invoke. Okay, just in the messages key, I am just putting one message, which is the content is how much is 3 times of 4. And I'm calling the same graph. I'm calling this same graph, but with now with a different input. Earlier, my input was Sherlock Holmes and blah, blah, blah. Now to see whether it will use the tools or not. So what it has done, first it's iterating through all the messages, it's printing how much is 3 times of 4, and then leaving LLM node, and my AI message is now a tool calls multiply, and these are the arguments.
So it is
Okay.
asking to use the multiply tool with three,
Exactly.
four.
Yeah, but we haven't yet done anything to execute this tool, but just understand that now my LLM is giving as an output this particular thing that you should call a tool. Okay, clear guys? So now my agent is saying I cannot answer this, rather you should use a tool. Now our next task is to add a tool basically which can execute this thing. If I give this output to my particular node, it should be able to execute this particular tool. Then my task is done. Okay, so we are moving to the automation step by step so that you understand everything. All right, anyone has questions, guys? Feel free to ask. I know, I mean, you may need to go to the recording one more time to understand, but this is how it is. Let me show you another example which will solidify your concepts. This time what we will do is we will use the tools node. Okay, so from the LangGraph, there is something called as the tools node and tools condition. So that's why we are using this LangGraph, because it is doing lot of things under the hood. They have already written those functions which can reduce the complexity. This LangGraph is a bit difficult to understand, but once you understand, there are a lot of things which it handles in the background. Once you understand, then you are basically able to develop the very sophisticated workflows as well. So they have also written some functions like tool node and tools condition, and we are importing it. So what the tools node class is doing, a node that runs the tools called in the last AI message. So this is basically a node, and what it will do, it will run the tools called in the last AI message. So we have seen, right, in our last flow, my AI is saying to call this particular tool, right? It's giving me the name of the tool and the arguments.
Yes, yes, for
Yes.
multiplication.
And if you
Yes,
remember our first lecture, what we were doing, the output, we were basically parsing using regex. Do you remember? We were using regex to see what is the name of the function which is there in the input and what are the arguments. Now we want to go one step further. We want to use the LangGraph APIs like tool node, which will recognize it automatically. Okay, there was a tool call initiated by my previous AI message. Okay, and it will automatically call this particular tool. Okay. So this is what is written. I am reading directly from this particular API, which the LangChain has written. A node that runs the tools called in the last AI message. It will automatically. It can be either used in a state graph with a message state key or a custom tool node message key, blah, blah, blah. Okay.
but it should have been called by human message, right? Because AI message was the first, I mean, tool or function executed. Human message was the second one, right? So
No,
it should
I'm
have called.
नहीं आप समझे नहीं. What I'm saying is, वो human message and AI message initially we gave it as an input.
Yes, yes,
Okay. The human AI message and human message was my input.
yes,
And then this, once I call the large language model, whatever response it produced now, that is this one. The final AI message after invoking the large language model, it's saying you should use a tool call basically. So if, and this is also getting saved in my messages state. ये जो मेरा
yes.
messages key है, this is getting state.
हाँ जी.
So now if this messages state goes to my tools node, in my tool node, what it will check is it will check the last AI message. This will be the last message to be appended, right? So it will check if the last AI message has a tool call, then it will call that tool. If it's not, if it's something else, if it's something like this one, this AI message, so this is not a tool call, right? So this is in the content, then it will
Yeah.
not call any tool basically. Otherwise, it will call a tool. If the in the output of the AI message, last AI message is a tool call, then only it will call the tool. Okay, so this is the automation they have already written basically. Okay, so now
Okay.
I go back. So again, I'm importing this start and message state. So this is a special class, right? Message state, which we use in our uh, input state. Okay, message state, which has messages as the key. Okay, and this is my tool node, and this is my tool condition. This tool condition will do what? As I said, it will also check the last message. It will see if there is a tool call, then it will route the flow to my tools node. Otherwise, it will give it to the some other node. Okay, either tools or end. ठीक है? So this is the tools underscore node will basically decide my flow. ये tools condition एक बार मैं let me show you, then I think it will be easy. So this is my function again. This is my tool set. There is just one tool. This is my chat OpenAI. I bind my tools, whatever tools I created, I bind with my large language model. Now I have LLM with tools object. Again, I'm writing my large language model node, which will basically invoke with whatever messages we have, and then it will print. And now I am defining my state graph. My input is messages state. First node is LLM node, and second node is my tools node. Okay, so I have to write tools like this. This is very strict. Basically, you have to write in the similar fashion, and you have to give a tool node with the whatever tools we have created as an input. And if I need to join them from start to the LLM node, from LLM node, basically it will a conditional edge, whether a tools condition will be there, which will decide whether to call the tool or to end. If it calls the tools, from tools, we are going to the end. Let me show you graph, then it will be easy to understand. Okay, so this is my graph. Start LLM node. If my output, if my large language model output says a tool call, it will go into the tools. The tool will get executed. My multiply tool will get executed and it will end. If my output does not say that a tool should be called, it will directly exit. It will go to the end. आ गया समझ में? So this, the earlier in the last session, we were doing all those regex and parsing and manually executing that function, right? All that has been now automated. Okay, so let's call it to understand it further. So now my message, if I say in the messages, how much is 3 multiplied by 4, what it should do? It should come here and then it will say, okay, I need to call a tool. It will go to the tools node. Tools node will use that signature, which this has provided to actually invoke the function, and it will produce the output and it will end basically. देख लेते हैं. So entering the LLM node, very good. So it's entering this one. And it says, this is my question. The user message, it has displayed how much is 3 times 4. Now it's leaving the LLM node, but it is giving me the signature basically. It should do a tool call. Okay, but it has not shown the output. Let me check. So we haven't basically in the tools node. It's automatically calling the tool, but we are not printing it basically. So either I should iterate the messages. Let me see. Okay, so 12 is the answer. So what I have done, I have just, once my tool node was called, it executed the function, and whatever the response was there, as I said, it get automatically appended to my messages. my state, right? So if I iterate through all the messages, so these are the messages I have. My first message was how much is 3 times of 2. My AI message was, dear, please call this multiply tool with 3 and 4. And my tools node basically did what? It multiplied the two numbers, and this is my output. So this was saved in my messages. So now you can understand the use of the message state, guys. In the message state, all my history is maintained basically. Okay. Let's say it was
Yes.
like adding the mass of all the planets. So it would, my question would be, add the mass of the planets multiplied by 5, let's say. Then first it will call that tool, get the mass of one planet. It will find the mass of the first planet. It will go back second planet. So that history is very important. Once it knows all the planet masses calculated, it will multiply it by 4, or first add and then multiply by 4. So that's why we are maintaining the history. The state is maintained throughout, but it's modified at every node basically. The state get modified at every node, and it's basically persistent throughout my journey. Okay? If we gone, if you want to go one step further, let's go with another example. This time, what we are doing is we are using another function, which is Celsius to Fahrenheit. This is my first tool. Okay, so now you know how to write the tools, define the function, define its input and output parameters properly, write a beautiful doc string, what your function is doing, what are its input parameters, and what's it's returning. This is my first tool. This is my second tool, get temperature. Okay, so this will get, it will convert Celsius to Fahrenheit, and this is get temperature for a city. Okay, and now I have two tools. So in the tools list, I will add both the tools, and I will say to my LLM, buddy, you have two tools. I will bind those tools with my LLM. Now it has access to these two tools. And now I'm defining my node. Again, messages state, printing input messages. First, I'm printing my existing messages, and then I'm invoking my LLM with the tools, and it's leaving. Before leaving, it's again pretty printing the response. Whatever response is there, it will automatically get appended to my messages. And this is my graph, my large language LLM node at the first place. And another node is my tools node. I have already explained you what is tools node. It will execute your tool based on the last message, if the AI message says. And this tools condition, which is again out of the box from the LangGraph. These two are from the LangGraph, right? We have imported them right here. Okay, tools node and tools condition. This tools condition will basically help me routing the request. Okay, this is for executing the tool, and this is for routing the request. From LLM node, it will go to the tools condition, and then we have again edge from tools to LLM node. So now we are going back to the LLM node with the answer. Okay, we are again going one step further. Here we were executing the tool, but we were exiting. Now, how the LLM will know that whether you have completed the tool? What we can do is we can go back to the LLM saying that this is the result of the multiplication. Okay, I hope you are able to relate. This is the mass of the Earth. It will give it back to the LLM. LLM, this is the mass of the Earth. LLM say, okay, now calculate the mass of the Venus. Okay, I will call the tool. This is mass of the Venus. Once I calculate all the masses, it will say, okay, now I have calculated, I have used get Wikipedia. Now I have to add. So it will call some other tool. That will be add all, calculate tool, add all the masses. It will say, okay, I have added, right? So there should be an iteration loop. So that's what we are going to do. In this graph, we are looping around our tool call. Start to the LLM node. We'll call the tool. It will get executed. Output will be given to, output will be given to the LLM node. Again, it will see the output, will decide what to do. Should it exit? Is the requirement over? Or if the answer is still incomplete, again call the tool, go back, that loop which we discussed in the first class, right? everything has got automated by now. So let's call this one. I have two tools. So let's see whether my LLM is able to understand my question. My question is, what is temperature of Paris in Fahrenheit? Okay. So
Okay.
first, what it should do? Anyone? What is temperature of the Paris in Fahrenheit?
Basically, first it will try to get the temperature of Paris.
Very nice. It will go to this particular tool. It will see this is the Paris. This will return 22. But the result is in
Celsius.
Celsius.
Celsius. So LLM will receive the answer, but it will see, oh, this is in Celsius. Do I have a
It will,
tool to convert it to Fahrenheit? It will then call another tool. Super.
yeah. But if the person is executing, I mean, we can also automate other way. Like if the person is in physically present in there,
Mhm.
and that country follows the Fahrenheit, then it will display. Suppose if currently I'm in India, and I
Mhm.
want to check the temperature, and I want to design in a way that because we don't use the Fahrenheit, right? We are used
Mhm.
to in Celsius, so
Mhm.
it will display based on the my current location. So that too also we can trace, right?
Yeah,
Based on
yeah.
the
I mean,
geography.
yeah, we can do that. But right now, my question explicitly says in Fahrenheit, right?
Yes, yes,
If I simply ask what is the
So I
temperature
think
of Paris,
in this case also, if we write is Celsius, then it will not call that conversion tool.
exactly. Yeah, so it will just give the temperature. Okay, we'll do that next. So let's understand this one. Entering what is the temperature of the Paris in Fahrenheit. Tool call. Which tool? Our get temperature tool. Paris should be the argument. My it has human message, tool call, and then my final answer.
yeah,
Okay, so we have seen our tool being called twice basically. We have done good amount of automation. Okay, so now you should be able to visualize the all the agenting things which are hearing in 2025, how this is basically working. Now, if you think of a very complex workflow, let's say there is a travel agent which will plan your travel, which will book your flight ticket, which will block your calendar, which will book your cab. It can also do shopping on your behalf if you are going into some meeting, right? It can do some shopping, like it will buy some dresses as per the location. If I'm going to the US or if I'm going to the Jaisalmer, then that attire can be different. So now you can think of those complexities being handled by these agents. So what essentially I can do is I can also create multiple agents, one agent being expert of doing one task. Maybe one is able to book tickets of the flights. So that will be my flight agent. Other is good at booking the hotel rooms. That will be my hotel agent. So there can be group of agents, and one orchestrator or the master agent will be there who will decide which agent to call basically. So just now, I think you should be able to visualize how this tool calling is so important. Your LLM will just be used as a mind. It will see your question, it will decide which tool to call, and then it will invoke the tool. The output will come back to it, and then it can further think and do some autonomous task. So this task cannot be done by LLM, right? LLM cannot do the multiplication. It cannot get the knowledge of anything which has happened after its cutoff date. And LLM training has stopped some time back. So if you want to know anything about current affairs, the president's visit to some country, summits and all, that can only be done. Your chat GPT application is also using so many agents in the background. Okay. I hope this was useful and you were able to understand, guys.
yes. We have to go back. I mean, I'm weak on Python, so I have to learn Python as well.
Yeah. So this is my whole flow. Okay. So now, I mean, what we can do is there are more sophisticated applications. If you want to build, we have to see how to, store these messages at some other place. And if there are multiple users, how we can create different threads, how we can, use short-term or the long-term memories. So those type of concepts we will learn in the next class. Okay. So, but yes, in order to start, I think you are uh, okay to start with this agent, and our first agent is already up and running. Okay. Anyone has any questions
Yeah,
before we close, guys?
yeah. One question, Surendra.
Yeah, yeah.
So basically, this is one agent that's calling multiple tools,
Mhm.
and as you mentioned that in a real world scenario, there could be multiple agents that will talk to each other basis
Right.
onto the requirement.
Mhm.
So there is a like LangGraph is also support that multi-agent orchestration, or is there a
Yes, yes,
different
yes,
framework?
yes. Yeah, I mean it does support. Yeah.
Okay,
It
like I can call a agent instead of calling, there could be one node that one agent and another node will be another agent.
correct,
Correct?
correct.
Okay, that is possible with LangGraph.
Yes, yes.
Okay, got it. And another question, like initially, like maybe I missed something. Like
Mm-hmm.
when we start writing first that multiply function, and then we see that it's not called, it's just giving a signature that tool should be call, or like tool calls it
Uh-huh.
provides a signature, but actual tool calling not happened, so we miss that. Adding that at that time we have not added the node of tool calling, that's the reason it's not called the tool, or what was that case?
No, no, LLM never basically calls any tools basically. It can only tell you which tool to call basically.
Okay.
Okay. So in order to call that particular tool, we have created this different node, which is again coming from the
Yeah.
LangGraph, which will understand, okay, my LLM is trying to say that a tool should be called. So it will handle that request. It will execute the tools. It will provide the output only. Okay.
Okay, got it.
Yeah.
So explicitly we need to create one node
Tools.
that basically the execution of a
True.
tool that actually execute that or that
Exactly.
function or
Exactly.
whatever.
Correct. Correct.
Okay, okay, yeah, thanks.
Yeah. Anyone else has any doubt? You can also ping me on WhatsApp even after the class if you feel something. I will share the recording. Okay. And that is all, everyone. Have a wonderful weekend.
Thank you,
Thank you.
Surendra. You
You
too.
too. Bye.
Thanks, everyone. Take care. Bye-bye.
Yeah. Yeah. Thanks.
Bye.
Bye.
Thanks, Surendra. Thanks.
Yeah.
Bye. Bye.